Hello and good morning. Myself Ranjan Kumar Vishwakarma, Product and Application Manager based at Heidelco Private Limited. Heidelco Private Limited was established in the year 2013 and is pivotal and plays a very pivotal role in terms of critical care equipments. This is a high-end electronic gas mixing based anesthesia workstation. It comprises of our 15-inch touchscreen, the auxiliary flow meter, the on-off switch, the backup flow control for oxygen. This is for central supply oxygen and nitrous oxide as well as air. This is for pin index oxygen and pin index nitrous oxide. This is selected at mounting for both the vaporizers. Vaporizers can be isofluorine, sevofluorine, enfluorine, desfluorine, compatible to all the vaporizers. This is our breathing system. If you are going from the rear side, this is the bellows assembly. This is the pressure gauge. This is single toggle switch, which is going to convert from the mechanical ventilation to the manual ventilation. This point is for mechanical ventilation. This is for manual. So once we are shifting from to manual, this is bypassed. This is an APL valve, airway pressure limit valve. This point is for inspiratory. This is for expiratory. The mixed gases are coming from the inspiratory. It comes from here, it goes to the test lamp, and again it reverts back to the expiratory port, from where it goes to the AGSS port. AGSS stands for Anesthetic Gas Skimming System. This is sort of like canister. How exactly to remove this thing? There is a lever over here. We need to push this lever on the back side. This thing will come down and we can take this soda lamp canister out. During the course of operation, the soda lamp, if consumed, it can be replenished. This is the workbench. This is an oxygen flush button. This is an ACGO port. This is the handle for maneuverability. These are 3 drawers which can be taken out. Yes. Central lock to make it sure that machine doesn't move, and within one click you can get it unlocked and it can be again locked in the central lock. This has 15-inch touchscreen. This is the power on self-test results, where the right indicator or the green indicator indicates that all those modules have passed. Since oxygen, this is not connected with an ET sensor, so this is not marked right now. We go to periodic check. We click on this. We go for the next step. We again go for the next step, and we click on done. Since this is an electronic gas mixing machine, so the second gas can be either air or nitrous oxide. Currently, nitrous oxide is being connected with the machine, so the secondary gas is nitrous oxide. The total flow, which is sufficient to deliver the set added volume to the patient, is being taken care of. Is 1 liter right now. This is 50% oxygen and rest 50% is nitrous. If you want to change it to 25% of oxygen, so depending upon the second gas, it will automatically adjust the second gas, which is nitrous oxide. 3 different waveforms: the pressure waveform, the flow waveform, as well as volume waveform. With all these modes of ventilation, with VCV, PCV, SIMV volume control, SIMV pressure control, pressure support ventilation, pressure regulated volume control, and heart lung machine. As the name suggests, pressure regulated volume control, it delivers the set volume at the lowest possible pressure. You can see it was delivering a pressure of 22. Got advanced modes of ventilation, which is called PRVC. As the name suggests, PRVC stands for pressure regulated volume control, which delivers the set volume at the lowest possible pressure. Apart from that, we have also got heart lung machine mode, which is HLM. As the name suggests, whenever the patient is put into cardiopulmonary bypass, each and every physical alarms is closed and set peak is delivered for the complete duration. The peak which is set for this current patient is 6 cm per. This machine has auto ID for anesthetic gas management system, for AGM, which can calculate your inspiratory and expiratory concentration of EtCO2, enteric carbon dioxide, your anesthetic agent. It can be either sevofluorine, isofluorine, enfluorine, desfluorine, or halothane, along with the MAC value, which is minimum alveolar concentration. This can also calculate the inspiratory and expiratory concentration of nitrous oxide, as well as in future oxygen also. These are the loops where we have got airway pressure versus volume loop, volume versus flow loop. When we double click on this, we get the complete loops. We can change this by clicking on this button. We can change the pattern. So this can be again changed. Again we can go to air pressure pattern. We can save the loop. The second breath will be in cascaded form with the previous loop. This is the rear panel of our high-end electronic anesthesia workstation. This is for the mains plug, for grounding, phase in neutral. This is the fan, dedicated fan. These are 3 different slots where this can be used to mount if we want to take a monitor. This can be taken, the power supply can be taken for the monitor or any other things. This is the COM port. This is HDMI port. From this HDMI connection, we can take the output and give to the slave display. This is a USB connector. This is RJ45 connector, which is used to connect this particular machine to a central server through RJ45 connection. These are the 3 different gas supplies. We have got central supply oxygen, central supply nitrous oxide, central supply air, with pin index cylinders for oxygen and nitrous oxide, along with AGSS gas terminal.